right, we're going to take a student from classroom TCV 5A. Tell us what you think your hypothesis of this scientific experiment would be.
I think the ball is gonna ball takes air, so it's gonna if you push it down, the ball is gonna come up, or either the water level will rise.
All right, that was an interesting comment. So you think the ball is going to? So I think the ball is going to stick to the air and it's going to rise as we push the glass down. So let's take a look and see what actually is going to happen as he lifts the glass over the ball and pushes down on it, and right there you can see the ball was pushed down. So what's inside the glass? Don't say nothing. There's air inside of that glass, and that air is taking up space. And as the glass is pushed down on top of the water, that water is not allowing any of that air to escape. So that air is stuck in the glass, and it itself is pushing not just the ball, but also the water level down as well. So don't worry if you didn't have the right hypothesis. That's why we're doing science here. You're better off making mistakes and learning from them than always having the right answer. So let's move on. Here you can see a demonstration of that same experiment. The air gets trapped inside the cup as the cup goes down. And then that trapped air then pushes the ball and the water level down. So now we know that air does take up space. You know, that's interesting because you think if air's taking up space, how come we move through it so easily? How come I can glide through the air? Well, that's because it is in the state of matter that's a gas. If those particles were more densely packed together, then we would consider it a liquid or a solid. Much like this cat who would wish this wall was made out of air. Oh, that's terrible. Let's watch that again. And the cat, you see, goes, and oh, it's not made out of air. So that solid wall, those molecules, those atoms that make up the wall, the matter that makes up it is very densely packed. With air, it's not so dense. And the molecules easily move out of our way, much like a liquid, as we move through it. And so we don't have the unfortunate incidents like the cat of slamming into things as we walk down the street. And here you can see a demonstration of those air molecules moving around the man as he's walking down the beach, very much like fish gliding through the water. Those molecules move out of the way as they just swim along through the water. They have water underneath supporting them, water on the top supporting them from all around, and so they just go along their merry way, and they don't even realize it. All right, so we've talked about the atmosphere. We've talked about the ocean of air that we live in. Now let's think a little bit about how a kite flies. A kite flies because you have the air pushing up underneath it, and as well as pushing on top. The air pressure is greater on the bottom than up above, and therefore you have lift. Now in this video, no, manta ray. In this video, you see a manta ray gliding through the water. That manta ray gliding through the water, it has air pressure, water pressure pushing up it from below, water pressure from above, and is able to just glide through that water very easily with the water pressure pushing up from the bottom. Now, very much like the manta ray, in this next video, our manta ray kite flies in very much the same way. You've got wind creating uplift, creating drafts that are creating higher air pressure underneath, or above, lower pressure below, and it's lifting the kite up into the air as that kite just kind of swims through the air attached to this string. So here we can see, class, that this ocean of air that we live in, where we can fly kites and birds can soar, they're not just soaring through nothing, they're soaring through the atmosphere. There's enough of the molecules and in the air that allow things to glide through it, very much like the manta ray glides through the ocean. All right, class, time to think. Getting back to our first question then, can you fly a kite in space? Why or why not? This time, I'm going to give you 45 seconds to come up with an answer now that you've learned the facts about matter and atmosphere, and I want you to see who can come up with the correct answer. You have 45 seconds. Uh-oh. No answers. All right. We'll go to the next question. Yes, a kite cannot fly in outer space. The question is why? Why a kite won't fly, you say? Because there's no air in space. So you may have your kites up there and it might float around, but it's certainly not going to fly because you need air to fly a kite. Next question, class, because it's question time. So we're going to give you some rapid-fire questions, 5 of them to be exact, and we're going to give you a short amount of time to answer these questions. Here we go. First off, we live in A, body of water, B, ocean of air, C, empty space, or D, none of the above. You have 30 seconds. All right, I see that we have a student in classroom TAI 5A. Can you please step to the microphone and tell us what you think the answer is?
There is B, ocean of air.
B for Boston, ocean of air is absolutely correct. We live in an ocean of air. Nice job. Moving on to the next question. What can the ocean then be considered? Is it A, an empty space, B, an atmosphere of water, C, a city of trees, D, a solid wall, or E, a body of air? You have 30 seconds.